continuing Unit 2 with Lesson 7. We'll start with problem 7.1, talking about two separate functions, function m and function k. Question 1 asks us, how are the two functions alike and how are they different? So we will start with discussing how these two functions are alike. Let's take a look at function m of x, and I notice I like to write it down because it helps me think about the function. X plus 3 times the quantity 2x minus 5. So with this function, I notice that I have two zeros. One of the zeros, x plus 3 equals 0. One of the zeros is negative 3. The other zero is 2x minus 5, set it equal to 0, solve this, and I would get x is equal to 5 halves. So I notice that I have two zeros. One of the zeros is negative 3, one of the zeros is 5 halves, and these are also the x-intercepts. Okay. Now if I look at my second function, k of x, I notice that 3 times the quantity 3x plus 3 times the quantity 2x minus 5. I notice here that this x plus 3 will give me the same 0 of x equals negative 3, and this 2x minus 5 will give me another same 0 of x equals 5 halves. So how are these functions alike? I would say they are alike because they have the same zeros. How are these functions different? Well, I notice that function k has a constant multiplied in front, so all of the outputs are going to be 3 times greater than the outputs of function m. So k of x is going to be 3 times bigger than m of x. Some other things I notice. I notice that they are both going to have be degree 2, and I can recognize that in m of x here. If I take x times the 2x, I get 2x squared. Okay, so that's going to give me a second degree polynomial function. And when I do the same thing over here, first I would distribute this 3, so then I would have 3x times that 2x, and it would give me 6x squared. So it's still going to be a second degree polynomial just like m of x1. So it's going to be a second degree polynomial as well. Okay, on to number 2. If a graphing window of negative 5 is less than or equal to x is less than or equal to 5, and negative 20 less than or equal to y less than or equal to 20 shows all the intercepts of the graph of m of x, what graphing window would show the intercepts of k of x? Well, for this one, I recognize that since my x-intercepts are the same in both functions, that would mean that my graphing window from negative 5 to positive 5 in the x direction should be fine. Okay, so I notice the x direction for my constraints on the horizontal axis of my graph, I shouldn't really have to change those. However, notice on my vertical axis, if I draw my vertical axis here, there's my x-axis, this is my y-axis. Notice in this first function here, we know that if I go up and down 20, I will fit everything that I need to see. However, in this second function, remember in this second function, we multiplied the function by 3, and we said everything was going to be 3 times bigger. So that would mean that instead of going down 20, I would have to go down 3 times farther. So this would be 3 times negative 20, or negative 60 should be the lowest value on my y-axis, and my highest value, well, I noticed that I started with a 20 in the graph of m of x. I know that it's going to be 3 times as high, so 3 times 20 should give me a positive 60. So my graphing window for this function, my vertical window should be from negative 60 to positive 60 inclusive, and my horizontal can stay the same, negative 5 to positive 5 inclusive. So this should be a pretty good graphing window for these functions.